I've got a load of pink toys here, but I prefer blue. It'd be nice if we could change the color like magic. In databases you can, with an update. An update statement overwrites existing values in the table. To do this, use the set clause to specify each column and its new value. You can do this for as many columns of the table as you want. Just remember to include a where clause, or you'll update every row in the table. Forgetting the where clause creates some problems. Firstly, it's rare you want everything to have the same value. Secondly, updating the whole table will take some time, particularly if the table is large. This can bring a third problem. Only one person at a time can change a row. Once you start an update, no one else can change the rows your SQL affects. Even if they want to change the values in different columns to you, they have to wait until you're finished. And by finished, I mean committed. If, for some reason, you forget to commit, other people wanting to change these rows still have to wait. This can quickly bring your database grinding to a halt. So, to avoid this, you need to commit after every single update, right? Not so fast. Sometimes you want to change several tables or rows at the same time, and it's important that either all the changes happen or none of them. Let's say I owe you some money and I'm finally getting around to paying you back. When I take the money out of my wallet, we need to update it to decrease the remaining cash. Then, when you get the money, run another update to increase the amount in yours. If we commit the change to each wallet immediately, we can end up in a mess. Say there's a disaster between taking the money out of my wallet and adding it to yours, so we can't complete the transfer. If this happens after we commit the change to mine, neither of us have the cash. To ensure this doesn't happen, either we want to ensure we update both wallets or neither. This is our transaction, the smallest unit of work which leaves our data in a consistent state. You commit the changes after updating both wallets, completing the transaction. Not before, or everyone could end up with no money. Often, your transactions will insert or update multiple tables. If you have different transactions affecting the same tables, you need to take care to ensure you avoid deadlock. Deadlock happens when two people each hold one resource, and then they want to get the resource the other person has. Neither is prepared to let go of what they have, but they can't continue until they've got the resource from the other person. Deadlock. Oracle Database automatically detects deadlocks and forces one session to stop requesting the other item, throwing an exception. This is an extreme way to solve the problem that you need to code around, or you're going to upset your users. But the correct way to deal with deadlocks is to ensure that they never happen in the first place. There are a couple of steps you can take to do this. First, ensure all your transactions change tables in the same order. This can be hard to coordinate in large applications. So, make sure you talk about this with your fellow developers and test thoroughly. Secondly, you can mark your intent to change rows with select for update. This locks the rows the query finds until your transaction completes. Doing this at the start ensures you'll be able to make your changes when you finally come to your update. This is particularly useful in long-running transactions which affect many tables. This can still lead to a lot of waiting, but at least everything will work. A final note on deadlocks. Unlike in some other databases, in Oracle, only changing rows takes out locks. Select statements never block others unless you add the for update clause. So, you've avoided deadlocks. There's one more thing you need to watch for with updates, and that's if they go missing. Most applications these days are stateless. This means reading data out of a table and writing changes back to it are separate transactions. This can lead to problems if two people are working on the same data at the same time. Say SQL is trying to deactivate the death query, and Jason just wants to make it look pretty. Both read the data out at the same time. SQL switches the weapon off and saves her changes. A few moments later, Jason makes it a funky red. Now, here's where things get interesting. The data Jason sends to the database still has the weapon armed. So, if your code updates all the columns, SQL's changes are lost. To avoid this, you need to ensure no one else has changed the data since you last read it. You do this using optimistic locking. There are several ways to do this. A common one adds a version number to each row. All clients must select this out when getting the data and then pass it back when saving. Your update then checks the version number is still the same. If it is, you update the columns and increment the version. Anyone who read the data before your update will still have the old version number. So when they save, nothing happens. You need to detect that the update did nothing. Then inform your users someone else made changes and check if theirs are still valid. This stops people continually overwriting each other's updates. Deadlock and lost updates are both issues which can lead to intense frustration from people who use your application. So, always test what happens when two people use your application at the same time, and code defensively to prevent these problems. You also need to take care if people can delete data in multi-user environments. We'll look at the ins and outs of wiping data in the next episode. Thanks for watching. Subscribe to my YouTube channel to learn more about database development and see SQL magic.